Good morning, good afternoon, and good evening, everyone, depending on where you are. Welcome to today's webinar titled Plastic Part Design Guideline Every Designer Should Follow. My name is Ravinandan Prakash. I am Marketing Manager at SCL and will be the moderator and host for today's webinar. Our speaker for today's webinar is Yogesh. Yogesh is subject matter expert at SCL and currently leading DFMPro product definition. With a diverse experience of 15 plus years in manufacturing, product design, and development, Yogesh provides consultative solution on the design to manufacturing space to the various industries globally. I would like to thank Yogesh for being with us today. So before I hand it over to the speaker, let me share the logistics of today's webinar. This webinar will be approximately for 30 minutes. Your active participation is important throughout the session. I have kept everyone on mute to avoid background noises. However, you can enter your questions and comments in the question box throughout the presentation. If time permits, your question will be answered following the presentation. In case time runs out, before we can get to all the question, we'll make sure the answer will email to you. So with this, I'll hand it over to Yogesh to begin the presentation. Over to you, Yogesh.
Thank you, Ravi, for brief overview. So before we start, let's discuss the agenda of this webinar. First, we will cover why plastic parts are preferred and their advantages. Then we will see injection molding plastic market trends, followed by key features of a plastic part design. Then we will see some guidelines with some illustrative examples. In the next part, we will cover the traditional and automated ways of manufacturing. Finally, we will demonstrate DFMPro, a design assistant software from HCL, which helps create the design right at the first time. So why are plastic parts preferred? New plastic materials now offers strength and stiffness comparable to the metals. New processing capabilities allow the manufacturing of a tight tolerance plastic parts. Combined with other benefits, many industries, including automotive, medical, aerospace, are replacing their metal parts with plastic. In case of automotive industries, for example, fuel tanks, vehicle parts, bearings, fasteners, and electrical component is already been replaced with the plastic component. Aviation industries also started to replacing heavy metals parts with the plastic parts. Now, let's see some advantages of a plastic injection molding. The first one is economical. Plastic is a low-cost raw material compared to metal. It is a cost-effective because it has a lower labor cost. Overall, the manufacturing cost per unit is low. Plastic injection molding generally requires only one process to get the finished part, whereas metal requires additional post-processing once it is molded. Durable. As we already aware, plastic are long-lasting. They do not corrode or oxidize easily. Metals are generally requires maintenance over time. Production and lead time. Plastic parts can processed and delivered quickly compared to the metal process. It is the most efficient method as its production output is high in comparison to other methods. Design. It is easy to design complex shapes and textures. We can create a complex shapes, branding, surface textures directly into a part without much tooling work. A complex design can be achieved with a minimum cost impact. Strength to weight ratio. As already we are aware, plastic tend to have a higher strength to weight ratio and highest strength to stiffness ratio. Let's Now let's see some key features in plastic part design for manufacturability. Ribs, bosses, undercuts, snap fits, pins, corner radius, text, shutoff angle, mold wall thickness are the key features of a plastic part design. Let's begin with some of the guidelines and their details. First one is the undercut. An undercut is a very common word for the mold tool department. Undercut creates ejection issue. Without side action, it is impossible to eject the part from the mold. Undercuts are typically protrusion or depression in the molded part. Undercuts are caused by the overall shape of the molded part. Adding side cores will increase the mold cost and molding time. The impact will be component ejection issues, sink marks, increased mold cost. As we already aware, so manual validation of a undercut is a time-consuming activity. Small undercuts portion may be missed during the validation, and manual validation will be limited for a flat parting line. In case of a complex plastic parts where the parting line is not non-planar, in that case, the undercut identification is more difficult. The design guidelines suggest avoiding undercuts to eliminate the complex slider mechanisms. Let's design guideline. Tip radius of a boss. Boss features are usually used to facilitate a mechanical assembly. A minimum radius at the base of a boss or the tip of a boss will reduce the stress concentration. Sharp corners are primary cause of a stress concentration, which lead to a part failure and poor flow pattern. The impact will be stress concentration, increased mold flow, material flow issues. General guidance suggests radius should be greater than or equal to 0.2 to 25 times the nominal wall thickness. As I mentioned, manual validation of this radius also a time consuming activity for the designer. Next one is the draft angle. So the next draft angle is a essential feature while designing a plastic component. A draft is required on all faces in the direction of a mold movement so that the part can be ejected from the mold easily. A sufficient draft angle reduces cycle time and improves the productivity. The impact will be component ejection issues, drag marks. Generally, the draft angle for 0.5 degree is recommended for core, 3 degree for cavity, and 0.25 to 0.5 degree for side cores. Another essential guideline would be wall thickness. Uniform wall thickness reduces the risk of a sink marks and differential shrinkage. The thick section on a part will also lead to a cosmetic issue, such as sink marks, build stresses, and create warpage issue. Uniform wall thickness allows the mold cavity to fill easier without restrictions. The impact will be differential rates of cooling, shrinkage, warpage issue, distortion. Generally, a wall thickness should be 25% of a nominal wall thickness. Coring is a method where the plastic is removed from a thick area and help to maintain the uniformity. Next one is the mold wall thickness. Many times designer will miss this design guidelines because it is related to the mold wall design. Mold wall thickness is one of the critical issue. It is due to the spacing between various features in the plastic parts. Ribs, bosses that are placed close to each other or wall of a part very near to each other will create the thin mold wall conditions. Thin molds easily break and frequently wear. The minimum allowable mold wall thickness need to be decided based on the process and material considerations. However, it is reasonable to have clearance of 1 mm between the features. The impact will be breakage of a mold, creation of a hot blade, thin material conditions, affect part quality. Is a rib parameter. Ribs is one of the most common feature added to the plastic part. Ribs are added to provide strength and stiffness to the plastic part. Tall ribs can create cavity filling issue, venting and ejection issue. Thick and deep ribs can cause sink marks and filling problems. If ribs are too long, supporting ribs may be required. The impact will be filling issues, sink marks, material flow, and warpage. General design guidelines would be the rib height should not be more than the 3 times the nominal wall thickness. Sometimes you can increase the height, it depends upon the material. Similarly, rib thickness at its base of a boss is around 0.5 times the nominal wall thickness. Draft angle should be minimum 0.5 degree to 1 degree. Second one is a boss parameter. Boss are normally designed into plastic parts to allow for the installation of a threaded inserts, guide pins, self-tapping screws. When it comes to maintaining an ideal height for the boss, it is critical to understand that if a tall boss is designed with an appropriate draft angle, it will still result in a thick section at the base of a boss. It will affect the cooling, which will result in a voids and sink marks. A tall boss result in a deep core hole that will require a long core pin. A general design guidelines for boss would be boss outer diameter to inner diameter ratio should be less than or equal to 2. The boss height to outer diameter ratio should be less than or equal to 3. Boss height to nominal wall thickness ratio should be less than or equal to 5. So these are the key features of a plastic part designs and its impact. Let's begin with the traditional approach to performing a DFMPro guidelines. So there are several reasons which contribute to delay in product launches. Some of them are due to rework in design, schedule, product pricing, and product quality. At the same time, the mechanical design of new product are getting more intricate and complex. To address these issues, organizations have traditionally followed manual design check, referred to design handbook, incorporated reviews, conducted piece of trainings. However, this process has multiple challenges and it's error prone, leading to multiple design iterations. High rework, poor product quality. Due to design complexities and schedule pressure, a designer may likely miss some guidelines during the design process. Minor misreview issue could lead to a major manufacturing and quality issue or cost escalations. Traditional review process may also lead to high number of engineering change orders, thus increasing the lead time of a manufacturing. Many design iterations and rework may lose time, efforts, and team's productivity. So let's see automation of a design for manufacturability guidelines. So what the solution of these issues? Many organizations are focused on reducing the ECO ECR, and they frequently ask the question, is there any way to automate the process and provide early design assistance? The answer is yes. DFMPro will help you. DFMPro is tightly integrated with popular CAD softwares like Creo Parametric, NX, and SolidWorks. DFMPro Parametric V10.0 will be released soon, which supports the Creo 9.0 latest version. Let's see the DFMPro demo. So for today's demo, we will use a part which is manufacturing from an injection molding. Once the part is open, one can see the DFMPro toolbar in a Creo Parametric. DFMPro is tightly integrated with the Creo Parametric, NX, and SolidWorks. Once click on a DFMPro toolbar, one can see the icons of a DFMPro. Start DFMPro, real-time mode of DFMPro, DFMPro rule manager, DFMPro help, and about DFMPro. Clicking on a Start DFMPro opens up the DFMPro interface, which contains the user input. Designer can simply configure the rule file, manufacturing process, material, and material grade. DFMPro automatically picks the material which is assigned to the CAD model. For this example, ABS material is assigned and DFMPro has picked ABS material in a material grade. After providing all these inputs, designer can simply click Analyze button. DFMPro automatically set the default pulling direction based on the part geometry. Now, designer can change the pulling direction if required. Designer can add secondary pulling direction. DFMPro provides flexibility to select a parting curve associated with the secondary pulling direction. After giving all these inputs, designer simply click Analyze button. Now the DFMPro started the execution. DFMPro identifies the features available on a plastic parts and run the checks. One can see the progress of a checks. Now the results are loaded. DFMPro result interface contains the three widgets. The bottom widget is the rules, the middle widget is the instances, and the top widget is the instance details. The bottom widget rule contains the rule name, which is categorized in a critical, medium, high order. Middle widget is the number of instances, and then top widget is the instance detail, which contains the actual value and recommended value. Let's see one of a recommendation, minimum radius at tip of a boss, which contains the two instances. Designer can simply zoom the instance to see the better feature. On top, one can see a fillet on a certain minimum radius value should be provided at the tip of a boss to reduce stress concentration. It provides the rule explanation. DFMPro provides a mini toolbar which contains zoom on instance, zoom to fit, review details, ignore instance, ignore all similar instance, and help. Clicking on a help opens up the DFMPro help page, which contains rule, its explanation, recommendation, configuration, and example for designer's clarity. Designer can go through other rules to see the details. Now let's deal with the review details. On mouse hovering, one can see the mini toolbar and then third option, review details. Clicking on a review details opens up a review details window and captures the automatic image. Designer can recapture the image if required. DFMPro provides flexibility for a predefined comments. Here I have added a critical. Designer can use a plus button to add multiple comments and capture image. Clicking on a OK button, critical comments and capture image will associated with that particular instance. In some occasions, the instance may not be critical. DFMPro provided a ignore facility for that particular instance. Clicking on a instance 4, one can ignore with the fourth button, ignore instance. After ignore, the ignored instance will get listed out in an ignored list at the bottom of a number of instances. One can restore if required. DFMPro provides an export-import facility for DFMPro results, which is available on top of a DFMPro widget. It allows the designer to share and load DFMPro results quickly. The next button is the report. DFMPro supports 4 type reports. One is Excel, XML, PDF, and advanced report, which is the e-drawing report. Clicking on a rule manager opens up a rule manager interface. One can see the rules, category, module, and criticality. For each rule, DFMPro provided an intuitive image and configuration values. Subject matter expert can configure the values as per the organization standard. Designer can simply open up a rule help for more detail. DFMPro provides more than 30 plus checks for injection molding, which includes snap fit mold parameter, boss radius parameter, cutout area, then minimum draft angle for text features, draft angle for bosses, and many more. For detailed demo, please contact DFMPro marketing team. After adding values, designer or subject matter expert simply click OK and save the rule file. Let's see one of the rule in detail, how the designer will act on a DFMPro recommendation. Take example of a minimum radius at tip of balls, where the two instances are shown. The instance detail shows the actual value is no fillet or partial fillet, and recommended value is 0.2 mm. And the review detail shows it is a critical. Looking this DFMPro recommendation, designer can simply modify the part and add a radius at the tip of a boss. Now the radius is added. DFMPro color shows yellow background, which tells that existing modification is not synced with the existing DFMPro results. So designer may rerun the analysis to see the modifications in terms of a DFMPro recommendations. Clicking on input and rerun the analysis. Analyze. So DFMPro automatically picks up the default pulling direction, what we have provided earlier. Then DFMPro will pick the material which is we assigned earlier and run the analysis. Now one can see the rule passed. Minimum radius at tip of a boss is rule passed. With these steps, the design engineer can quickly perform critical checks and ensures the checks are passed. With this information demo, DFMPro supports other manufacturing process including machining, turning, drilling, thermoforming, injection molding, die casting, composite, and many more. Thank you.
Thank you, Yogesh. The session was really informative. So we are now open for question. Do type your question in the question window and we'll take question one by one. Great. So we have first question. Does DFMPro integrated with the PLM environment?
Yes, DFMPro can seamlessly integrated with PLM software like Windchill and Teamcenter. It maintains the part revision based on the DFMPro results and report traceability.
All right, thanks. Thanks, Yogesh. We have the next question. Can DFMPro be customized?
Yes, definitely. DFMPro can be customized. DFMPro provides an API that allows you to define the new rules proprietary, and those new rules will be seamlessly run with our product tools. Yes, it can be customized.
All right, thanks. Now we have a third question as well. Does DFMPro support the multi-body functionality that Creo Parametric introduced in the V7.0 and above versions?
Yes, DFMPro supports multi-body capability, what Creo has introduced in 7.0 onwards. So DFMPro supports sheet metal, injection molding, additive manufacturing as a multi-body design. In injection molding, one can run the two-shot molding, over molding, multi-cavity molding, etc.
All right, I think we are well on time. So let's take the last question for the day. Does DFMPro supports PMI and has any rules on that?
Yes, DFMPro rule supports the PMI information. So we have developed a couple of rules which is use the PMI information which is available on a CAD. So we have developed a geometrical tolerances rule, dimension tolerances rule depend upon the PMI. Yes, DFMPro supports the PMI information.
All right, thanks. Thanks, Yogesh. So we are almost on time. We hope you enjoyed the webinar. And as promised, we'll be sending answer to all the unanswered questions over email. And we'll be sending a link to a recording in next few days. In case you have any remaining question, please write to dfmpro.marketing@scl.com. I'm repeating again, it's dfmpro.marketing@scl.com. You can also visit our website www.dfmpro.com for more information. Thanks again for your time. Have a good day.
Thank you.